The great white continent is losing its ice. The Antarctica ice sheet, which has the biggest potential for sea level rise.
On July 12, 2017, one of the largest icebergs ever recorded, named A68, broke away from Antarctica's Larsen sea ice shelf. Nearly 1,100 feet thick and more than 7 times the size of New York City, a 68 was so enormous that it would take almost 4 full years to melt completely. But the craziest part about this iceberg wasn't its size. When the ice disappeared, it uncovered a world that had remained hidden for as long as 120,000 years. And what scientists found there didn't just shock them, it completely changed the way they understood Antarctica. So how did the A68 become the most studied iceberg in Antarctica's history? And what exactly was hidden beneath it for all those thousands of years? Let's dive in. Warning before the collapse. The collapse of Larsen Sea was not an isolated event. It was the third and most terrifying act in a trilogy of environmental destruction along the Antarctic Peninsula. Since the 1950s, glaciologists from the British Antarctic Survey had been quietly monitoring a vast chain of floating ice shelves along the Weddell Sea, on the eastern side of the Antarctic Peninsula. Together, these ice shelves were known as the Larsen Ice Shelf. But to make them easier to identify, scientists divided them into 3 sections: Larsen A, Larsen B, and Larsen C. For thousands of years, these giant shelves appeared remarkably stable. But by the late 20th century, something had started to change. The Antarctic Peninsula was warming almost 5 times faster than the global average. Scientists began spotting new cracks, shrinking ice shelves, and glaciers moving faster than before. They didn't know exactly where it would lead, but they knew something was no longer right. Then, in January 1995, Larsen A suddenly collapsed. Around 1,500 square kilometers of ancient ice, nearly the size of Greater London, broke apart in just a few days. It was a shocking sight, but many scientists still believed it was an isolated event. Unusual, yet not the beginning of a much bigger problem. But they were wrong. 7 years later came the warning no one could ignore. In early 2002, Larsen B suffered one of the most dramatic ice shelf collapses ever recorded. Over just 35 days, more than 3,200 square kilometers of ice, a floating platform that had existed for nearly 12,000 years, shattered into thousands of pieces. Satellite images looked less like a glacier breaking apart and more like a giant sheet of glass exploding. But what frightened scientists the most wasn't how much ice had been lost. It was what that ice shelf had been protecting all along. To understand this, think of an ice shelf as a giant wall. It holds back the enormous glaciers resting on the land behind it. So, once Larsen B collapsed, that wall was gone. The glaciers rushed toward the ocean up to 8 times faster than before, carrying huge amounts of ice with them. And that discovery changed everything scientists thought they knew about these floating ice shelves, because for the first time, they had real measurements showing just how quickly glaciers could race toward the ocean after an ice shelf collapsed. It became clear these weren't just giant slabs of floating ice. They were one of Antarctica's most important natural barriers, helping keep the continent's ice locked in place. That's why, when satellite specialist Professor Adrian Luckman and other researchers noticed a giant crack spreading across Larsen Sea in 2014, it became one of the most closely watched cracks in the world. The European Space Agency's Sentinel-1 satellites and NASA's Landsat missions tracked it constantly, measuring every new kilometer. By mid-2017, scientists weren't simply watching another crack in the ice. They were waiting to find out whether history was about to repeat itself. And when a 68 finally broke free, scientists from around the world rushed toward Antarctica, because, for the first time, they had a chance to explore a world that had been hidden beneath the ice for more than 120,000 years. The race to see the unknown. On July 12, 2017, the moment iceberg, a 68, broke away from the Larsen sea ice shelf. Something extraordinary happened. It wasn't just one of the largest icebergs ever recorded. It had also exposed nearly 5,800 square kilometers of seafloor that had been sealed beneath floating ice for as long as 120,000 years. No one knew exactly what waited below. Was it nothing more than mud and rock? Or had the ice preserved something far more unusual? And if any form of life had managed to survive there, how could it possibly exist without sunlight for so long? For scientists, those questions started a race against time. Because the moment the ice disappeared, the hidden environment began to change. Sunlight could now reach the water. Ocean currents would bring in fresh nutrients, and new species would slowly move in. Scientists knew they had only a small window to see this untouched world before it changed forever. So, the British Antarctic Survey quickly began preparing an expedition aboard its research vessel, the RRS James Clark Ross. On board were underwater cameras, seabed sampling equipment, robotic instruments, and ocean sensors, all built for one purpose: to explore a place that had remained hidden beneath the ice since before modern humans existed. But there was one problem. Reaching it was going to be far more difficult than anyone had imagined. The newly exposed area lay deep inside the Weddell Sea, one of the most difficult and unpredictable bodies of water on Earth. There, thick sea ice is constantly pushed around by powerful winds and ocean currents. A route that looks open in the morning can be completely blocked by afternoon as massive slabs of ice drift together. Still, scientists couldn't afford to wait. In early 2018, the RRS James Clark Ross set out toward Larsen Sea. But as the ship pushed deeper into the Weddell Sea, satellite images showed the route closing ahead. The sea ice had become too thick to cross safely. After days of searching for another way through, the expedition was forced to turn back. But it wasn't the only setback. Another major attempt, led by the German research icebreaker Polarstern, also struggled with the heavy sea ice. And with that, it became clear that Antarctica wasn't going to give up its secrets easily. However, scientists didn't stop. In the years that followed, as sea ice conditions gradually improved, an international expedition led by Germany's Alfred Wegener Institute finally reached parts of the newly exposed seafloor. And the moment they lowered the camera into the darkness below, the first images revealed a world no one had expected to find. A hidden world revealed. Instead of a flat, muddy seafloor, the cameras revealed a landscape that looked more like a lost continent than the bottom of the ocean. And to understand what they were seeing, researchers turned to multi-beam sonar. Think of it as an underwater flashlight made of sound. By sending sound waves to the seafloor and measuring the returning echoes, the ship built a detailed 3D map of the hidden landscape. And what emerged was remarkable. Beneath the ice lay an ancient world of enormous ridges, deep glacial valleys, and vast troughs plunging more than 1,000 meters deep. The smooth bedrock showed where massive rivers of ice, not liquid water, had slowly scraped and polished the surface over countless centuries. It was almost like discovering another Antarctica, hidden beneath Antarctica itself. But that wasn't the biggest surprise, because when the cameras were lowered onto those rocky slopes, they didn't find an empty seabed. They found life, and far more of it than anyone expected. Pale glass sponges built from natural silica that forms tiny glass-like skeletons rose from the seafloor like silent towers, and strange shrimp-like crustaceans covered the rocks. Long ribbon worms, some reaching nearly 2 meters in length, slowly moved across the bottom. This wasn't an ecosystem barely holding on. It was thriving beneath ice that had sealed this place off for as long as 120,000 years. That immediately raised an even bigger question. How could so much life exist in a place where sunlight had never reached? Without sunlight, there can be no photosynthesis, the process that supports almost all life on Earth. So where was the food coming from? When scientists searched for the answer, they didn't find one single source. They found an entire hidden system that no one had imagined. Powerful ocean currents had quietly been carrying tiny bits of organic material from the open ocean beneath the ice for thousands of years. Scientists call this marine snow. It isn't actual snow, but a slow, continuous rain of microscopic organic matter drifting through the water. But there was something else, too. Hydrothermal vents. These are the cracks in the sea floor, where hot, mineral-rich water rises from deep inside the Earth. Instead of relying on sunlight, bacteria around these vents use chemicals from the water to produce energy, forming the base of an entire food chain. Now, these discoveries were so important that they soon drew interest far beyond Antarctica. Even NASA's astrobiology program began studying this place. Why? Because Jupiter's moon Europa and Saturn's moon Enceladus are both believed to hide vast oceans beneath thick layers of ice, much like Antarctica once did. If complex life could survive beneath Antarctica's frozen roof for thousands of years, then perhaps those distant oceans weren't as lifeless as scientists had once imagined. In other words, this frozen corner of Antarctica had become a natural laboratory to understand where life might exist beyond our own planet. But while scientists were busy exploring the hidden world below, the iceberg's journey. The iceberg, a 68, broke away from the Larsen sea ice shelf on July 12, 2017. But what happened next surprised almost everyone. It didn't disappear after a few weeks, or even a few months. It kept drifting across the Southern Ocean for nearly 4 full years. During that entire journey, scientists from organizations including the British Antarctic Survey, NASA, and the European Space Agency tracked it with remarkable precision, recording almost every change in its size, shape, speed, and direction. But why would researchers spend 4 years following a single iceberg? The first reason was simple. This was one of the rare opportunities to watch the complete life of a giant iceberg from the moment it was born until the day it finally disappeared. Every satellite image helped scientists understand how massive icebergs drift, rotate, crack apart, and slowly melt as they travel through the Southern Ocean. That information helps improve climate models and predict how future icebergs may behave. But there was another reason. A 68 held roughly 1 trillion tons of ice, containing well over 1 trillion liters of frozen fresh water. As it slowly melted, all of that fresh water was released into the surrounding ocean. Now, as the Southern Ocean is naturally very salty, scientists wanted to understand what would happen when such a huge amount of fresh water mixed into it. Would it change ocean currents? Would it affect water temperatures? Could it influence marine life hundreds of kilometers away? For the first time, they had the chance to watch those changes happen in real time. Then, there was the third reason, and it was perhaps the most fascinating of them all. Locked inside the ancient ice wasn't just frozen fresh water. It also contained tiny amounts of iron and other minerals that had been trapped for thousands of years. As the iceberg slowly melted, those nutrients were released into the surrounding ocean, feeding phytoplankton, tiny plant-like organisms that form the base of almost the entire marine food chain. Scientists wanted to see how far those nutrients would spread. The South Georgia Crisis. By late 2020, a 68 was no longer drifting through the open Southern Ocean. It was heading straight towards South Georgia, a small island in the South Atlantic. On a map, it looks tiny. But for wildlife, it is one of the most important places on Earth. More than 450,000 breeding pairs of king penguins raise their chicks here. Over 1 million pairs of macaroni penguins nest along its shores. Around 95% of the world's Antarctic fur seals breed on the island, alongside huge populations of southern elephant seals, and almost all of them depend on one small animal: Antarctic krill, a shrimp-like creature that forms the foundation of the entire food web around South Georgia. As a 68 drifted closer, scientists became increasingly concerned, but not because they thought the iceberg would crash into the island. The real danger was beneath the surface. Although only part of a 68 was visible above the water, nearly 200 meters of the iceberg extended below it. Scientists feared it could reach the island's shallow underwater shelf and become stuck on the seafloor, creating a giant frozen barrier across important feeding routes. And the timing couldn't have been worse. It was the height of the breeding season. Parent penguins and seals regularly leave their young behind while they swim out to sea to hunt for krill and fish. Then they return to feed their chicks. If a massive iceberg blocked those routes, many adults would be forced to swim hundreds of extra kilometers. For weeks, satellites watched as a 68 moved closer and closer. Then, in December 2020, something unexpected happened. As the iceberg reached the powerful Antarctic circumpolar current, the world's strongest ocean current, enormous forces began pulling its massive body in opposite directions. At the same time, warmer ocean water weakened it from below. Under that enormous stress, the giant iceberg began to crack. It split into several smaller pieces instead of becoming permanently stuck near the island. But the danger wasn't completely over. As those fragments melted, they released huge amounts of fresh water into the surrounding ocean, temporarily disturbing local krill populations. However, they also released the same ancient iron and other minerals that had made A68 so important to scientists in the first place. The pulse of the planet. The lesson Antarctica was trying to tell us wasn't just about one iceberg breaking away. It was about how closely our entire planet is connected. Let's quickly understand what that means. Every winter, as seawater around Antarctica freezes, the ice leaves most of its salt behind. That makes the surrounding water extremely cold, salty, and heavy, causing it to sink deep into the ocean. This sinking water helps drive a massive system of currents that moves heat, oxygen, nutrients, and even carbon around the world. Scientists call it the global ocean conveyor belt. When giant icebergs like A68 melt, they release huge amounts of fresh water into the ocean. That fresh water makes the surrounding water less salty, making it harder for the cold water to sink. If enough fresh water enters the system over time, this global circulation could begin to slow down. As a result, it could affect weather patterns, marine ecosystems, and even the ocean's ability to absorb heat and carbon dioxide. So, this is what a 68 taught scientists about just how important floating ice shelves really are. So, here we are. A 68 may have disappeared, but its greatest legacy wasn't its size. It briefly opened a door to a hidden world, revealed how deeply connected Earth's oceans really are, and reminded scientists how much of Antarctica still remains unexplored. Now, what was the most surprising thing you learned about iceberg A68? And if a single iceberg could reveal so much, what do you think is still waiting beneath the rest of Antarctica's ice? Let me know your thoughts about this in the comments below. And if you enjoyed this video, don't forget to hit the like button and subscribe for more fascinating stories like this. Thanks for watching, and we'll see you in the next video.